Alright, so this video will focus on 9.1. And with 9.1, we're going to start with actually graphing, because this whole lesson is about scatter plots and making lines of best fit. So the very first thing to remember is that we have our y-axis and our x-axis. And if I look in an ordered pair like 1, 6, the 1 is the x and the 6 is the y. So if I go over 1 on the x-axis and 1, 2, 3, 4, 5, 6, it's right here. That is 1, 6. Now this shouldn't be confused with slope, which is m equals y over x, or the change in y or the change in x. Make sure you don't mix these up with ordered pairs in plotting. It's really important, and it's an easy thing to get confused. So again, for 4, 3, I have 2, 3, 4. That's the 4, that's the first one. And 1, 2, 3 is right here. Then I have 0, 4. So 0 and 1, 2, 3, 4 is right here. Next one is 5, 2. Next one is 3, 3. And then 5, 0 over here. So if I look here, there's kind of like a pattern. It almost appears, it's kind of hard to see, but it almost looks like it's kind of going this way, right? So it's like going downwards. And what we're going to learn in this unit is that this is called a negative slope. And it's a negative correlation. It's not linear right now. It's a scatter plot. But what we're going to do is try to find a line of best fit so we can predict other prices. And that's really what the focus of this whole lesson is about today. So here's the same thing I drew over here. So we want to construct a scatter plot and interpret it as well. So if I look here, I have these different, I have the ounces and the diameters or the circumferences of these balls, right? And we're going to go through here and we're going to figure out if there's some sort of line of best fit to go in here. So I have my weight on the bottom and my circumference, it looks like depends on the weight, the way that we have this set up, because this is the dependent variable and this is the independent variable. And what it wants to do is we want to write this circumference and we want to plot them as well. So we're going to go through here and we have to figure out first of all our scale, right? So if we're doing weight, it looks like the smallest weight that I have is right around 2. And the largest one that I have is right around 21. So I go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I could probably get most of it on there. So I'm going to quickly go through here and make this a little bit bigger here. And let's go through it and plot this out. So go here. So let's just plot these points. So again, I have my 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And I don't have that 21, but I'm really close. And then my circumference, if I look here, it looks like the largest circumference that I have is 30. And if I go here 2, 4, 6, 8, 10, 12, 14, 16, 8, we're not going to make it. So I probably want to go by like 4s, let's say. So I'll do 4, 8, 12, 16, 20, 24, 28, and then 32. All right, so now I got to plot these things out. So my first one is 21, 30. So I'm going to go to 21, which is over here somewhere, and 30, which is up here. So I'll put it out. And my next one is going to be 5 and 9. And I'm just going to keep on plotting these out until I get all of them. All right, so I plotted out all these points, and I did the two things. I first of all made my scale. That would fit most of the data. Of course, I had to go to 31, but we get the point. And then I defined it for this one as well. So this one I went by 2s, this one I went by 4s. I just wanted to make the scale work for both of them, right? Now, if I look here, what we're going to be focusing on again in this chapter is really looking for lines of best fit, because right now this is not linear. But if I want to take a guess as to what it should be at 18 ounces, there's sort of a pattern here. It appears like it goes kind of in an upward pattern. So I'd call it a strong positive correlation. And again, through this unit, we're going to try to find a line of best fit. So that way we can determine if I had 16, what's the best guess that that should be. So that's what we're going to be focusing on today. So we're looking for the relationship between the weight and the circumference. If I look back here, it appears like the bigger the circumference, the more it weighs. I think that's a pretty good observation. Second one, do you think it's a positive or negative linear or nonlinear. So again, I'm going to look back at this. If I look here, I think that it's a positive linear correlation. I mean, it's not linear, but it's going to be kind of going in that direction. So it says a bowling alley has 225 ounces at 27. So if I look here, it's going to be pretty heavy. That's going to be way off the chart, right? Like that will be way up here. For the weight, it'd be like way over to the right. So that's what it's asking for. So it has 225 ounces for 27. So it's kind of like 27 is right here, and 225 is way out. So it's kind of a major outlier because it'd be way over to the right. And basically what we're looking at is we're looking at this kind of stuff here. So we have 3 different graphs, and if you look at them, again, they're all scatter plots, right? This one here, though, it kind of you could tell it appears to be going up kind of to the right. It's not linear, but it seems like it's that pattern. This one has like no correlation at all, and this one is a negative correlation. So as I go from left to right, it's going downwards, right? So it says here, month of birth and birth weight for infants at a daycare. Well, I don't think that really has anything. I don't think there's any correlation there, but birth month and weight, I don't know. Quiz score and test score for each student in the class. Well, hopefully, the more students you have, the higher the test grade that you have, right? That's what you're hoping for. So I think this would probably be it right here. So quiz score and test score, meaning the higher they did in their quiz, the better they probably did in their test, right? And the last one is age of the value of a laptop. So if this is my age and this is the value of a laptop on this side, the older it gets, the cheaper it gets. Like the value of it goes down, right? So it seems like this matches up with B, this matches up with A, and this matches up with C. So this one here says the table shows this, sold at different stores. Write the order pairs from the table and plot them on a coordinate plane. So if I just look here for a second, this is 25, 50, 38, 90. This has gone down. 32, 142. This is kind of going down. This is going down. It appears like when I plot this out, and again, I have to make my scale on both sides here. The price would probably be down here. I'd call that my X, and my number of sold is my Y, because my number of sold depends on the price, right? So basically what it looks like is the higher the price, the less that I'm going to sell, right? So if I'm at $50, I'm going to sell 75. But there does appear to be some inconsistencies as you plot this out. But I'm guessing that as I would plot these, and if you would actually plot these out, I'm guessing it would kind of go in a negative correlation, that the more expensive it is, the less of them you're going to purchase or sell them. And that's kind of what stores do all the time. They try to figure out the best price to make the most money. So a scatter plot is a graph that shows the relationship between 2 data sets. They're graphed as ordered pairs in a coordinate plane. That's really what we're doing today. So here's an example. If I look at this one for a second, it says how many. This is the scatter plot of calories versus fat. It says how many calories are in a sandwich that contains 17 grams of fat. So I go to 17 grams of fat, which is right about here. And it looks as though there's 14. I'm just looking at that ordered pair, right? It's about there. So that's what I have for the first one. The second one says draw a horizontal line. That's what we did here. Drew the horizontal line at 17, so it's about there. So it says how many grams of fat are in a sandwich that contains 600 calories. So 600, draw my line here. It looks like it goes to 30, right? So I just go to 600, go to the point, and go down. So what tends to happen to the number of calories as the number of grams increase? Well, the calories and grams, they both seem to go up, right? It seems like it's a positive correlation. It's getting more on both sides. All right, so the next one is, what if a sandwich had 650 calories? So if I had 650 calories, which is right about here, it looks like it'd probably be right around 30, 35, right? Right about here. So that'd be about 35 grams of fat. And then here's my example 2. It says, describe the relationship between the data, identify any outliers. So if I look at this, I mean, again, if I look for a line of best fit, and we'll find better ways to do this, but essentially this line of best fit would be like right about here. And that just means draw a line where most of the points are on. Well, this one here seems like it's a major outlier, doesn't it, compared to the rest? This one here, there doesn't seem to be any correlation. They're kind of all over the board. So I really don't know what this is. Um, there's definitely some clusters right around here. There's some clusters up here, but this right here is really hard to determine. I'm not sure if there is a relationship. And that's what it says. So that's really the lesson today for